Okay, so I welcome everyone on this Geospatial series. So today we will be learning a bit more about what is Google Earth Engine and what kind of things that you can do on this platform. So before starting this session, I would first like you to tell you from the very start, like what you have to type. You have to just type Google Earth Engine on the browser. Okay. This is the homepage of Google Earth Engine. So you can read more about you, you can read more about this page. What are the things that is available on this platform? What are the things that you can do? So basically, there are few things that is very important in this page. First of all, the one link is here in the name of datasets. So if you will go to this page, you will see all the remote sensing data set that you have heard. That is given by either it is provided by NASA or the JAXA, that is Japan Space or European Space Agency. All those data sets are available in this Earth Engine data catalog. So suppose you want to work on some temperature related data set, then you can browse this page. If you want to work on climate related data set, then you can go through this link. Similarly, like if you want to work on atmospheric or weather, or if you want to work on some satellite imageries like Landsat, Sentinel, MODIS, and there are some high resolution imagery also of the America and some other countries. And there are some geophysical data set also, like terrain data set, land cover data set, cropland, and there are some night lights imagery. So all the imageries which are hosted by NASA, Japan, Europe, or and France, all those data sets are provided here. So what is the feature of this interface is that you can directly call this data set in your window, and you can simply process them. You don't have to download all the data set one by one and then process it as you do in your QGIS or ArcGIS. That thing is not required. You can directly process all your data sets here, and the resultant data set you can directly export. So this is the main feature of this Google Earth Engine database. So in the dataset page, you will get the information about the all the dataset that are available. Then second most important link is this time lapse. Suppose you want to work on some land use land cover change feature analysis, or suppose you want to work on what are the changes that has occurred over certain place from a period of time. So what this interface does, this interface has created a certain kind of time lapse. In this page, you can directly search for your desired area of interest. Like you want to see about Bangalore urbanization. Then you just type here Bangalore and click it here. So this web page will take you towards Bangalore, and depending upon your internet speed, you have to wait for some time. And what you will see in the bottom, that the location is set to Bangalore, and you could see that there are years given at the bottom side. And if you will click on this play button, you can see what are the changes that has occurred over this place. Suppose you want to work on urbanization of Bangalore and its effect on the nearby wetlands or nearby water bodies. So you will search Bangalore here, and you will go to this place, and then you will change the date. You will just click on the date, and you can easily see this year. Suppose if you will see in the year 1984, this is my piece of land, and if you will look on 2020, see a lot of urbanization has occurred, and this lake has got shrunk. Uh, yes. And if you will play this button, slowly you can see how you can visualize that the time lapse, that how with time the urbanization has occurred. So this link will help you. This Earth Engine time lapse link will help you to get to know the place. Means what are the changes that has occurred over certain place. Similarly, if you want to see, suppose you want to work upon morphology of a river, means how the river course has changed. So you suppose you will search Uttar Pradesh. Hello. Okay. Okay. Suppose you want to work, you want to see what kind of changes that has occurred over what are kind of morphological changes that has occurred over river Ganga. If you just want to visualize, then you will search UP and you will see this. See here, river Ganga. It is shown here. Now, when you will click on the play button, you could easily see. If you will zoom into this place, with time you can see how the river course has changed. What are the morphological changes that has occurred? You can simply visualize, and here is the option to decrease the or increase the speed also. So you can decrease the speed, or you can even pause and play and click on the yes. Using this clicking using this interface, you can easily see what are the changes that has occurred or how the river course has changed with time. So likewise, if you want to, whatever is your work, whatever is your topic of interest, you can directly search you can directly search your study area here, and you can simply visualize using this time lapse feature of Earth Engine. Now the third, the very important feature which we use of this interface is that is the page of this Google Earth Engine, means this code interface page. So how you will go to that page? You will type Google Earth Engine here. Okay. And there is an option. Suppose if you don't have the account, then you have to first sign up here. But since I have an account here, okay. So I will go to the code editor, or you could simply type this uh, link also, code Google Earth Engine. You could even simply type this code.earthengine.google.co.in, and you will go to this page. Now coming after coming to this page, uh, there are certain windows in this page. The left window is where you will store all the code. In the center window, you will type all your required codes, and you will see the result. And in the bottom interface, you will see whatever the data that you have fetched, that result will be shown here. And whatever the thing that you have written in the form of a print, that thing is displayed in this console window, this right side. So this is the overall interface. And if you want to know the detail about this page, you can simply go to this question mark, and you can simply go do this feature tool. This feature tool will explain you what are the left panel, what is the right panel, everything. What are the things that you can do here. Just clicking on next, you will simply get to know about each of the buttons which is provided in this interface. Okay. So you can go to question mark and then feature tool. So by doing this feature tool, you will get to know about this whole interface. Now we will start with some basic examples, that calling some data set, and we will try to export it. So how we can do that? Suppose we want to work on some terrain visualization. Okay. So terrain, we know that the terrain work is done with the help of digital elevation model. So we will try to call upon some digital elevation model. So here, for example, we will call SRTM. So how we will call it? We will search for SRTM. Okay. And see, there are various options which is given. So since we want to work upon 30-meter SRTM, so we will import this NASA SRTM digital elevation at 30 meter. We will click. We will click on import. After clicking, you will see a link is generated here by the name of NASA SRTM digital elevation. You first have to click on this link, and you have to read about this key. What is that? For what date this data set is available, date of availability, who is the provider, then what is the description of this data set, how it is produced, how it is made. Suppose you want to use this dam, then whom you want to cite, whom you should cite. So all these details are given. So the details that we will be using is the information of bands. We will click on these bands and we will see but by what name this SRTM model could be called upon. So here the name is given as elevation. So in our code we will type elevation, means from the NASA USGS SRTM 003 we will call the band elevation to get the elevation of any place. And suppose and what is the code, what is the whole code that you have to type. That code is given in their dataset page. So how we will go to that page? We will go to that page by clicking on this link, the upper corner link. We will click, and whenever we will click is on that link, a new page will open, and we will go to the bottom of that page, and you will see that a code is written. So what we will do, we will just copy this code using this button, this right side corner copy. We will copy this code and we will just paste it here. Okay. So all the code for every data set is given in their data set page. So whatever image we want to work on, whatever satellite imagery we want to work on, we will just search it here. We will click on import, and then after clicking on this link, we will go to its catalog page, and from that catalog page, we will copy that code and we will paste it in our screen. Or we can even click here at the bottom, open in code editor, and a new page will be open with the code written. See, a new page will be open and that code is already written here. So there are two methods. Either we can copy it here and paste it to our code panel, or we can simply click on open in code editor and this will open. So after pasting it here, we will just click on run. So see, after clicking on run, there are two things that is being provided here. One is slope and other is elevation. So first of all, we will try to visualize the elevation. So I am just hiding this slope part. So what is the first line? First line is saying that we have taken a variable named dataset. What is the name of that variable? That variable is storing this information, this collection snippet information, this e.image USGS SRTM 003. So that we have pasted here. Okay. And as we have seen, the name of the band was elevation. So what we have written, we have created a new variable name elevation, or whatever name we can click. Suppose you have write just ELE, and ELE stands for elevation. And in this variable, what we are storing, that from data set, this data set, just select elevation. We just look carefully how we are typing. Dot select and then bracket, and then in a inverted comma we will type the name of the band. The name of the band is elevation. Okay. Now I will click. Now we will try to visualize it. To visualize, we will type it here, map.add layer, and the name of the variable. The name of the variable is ELE. And suppose whatever with the range, we will just, for the visualization purpose, after comma we will give the visualization command. So this for visualization we will type minimum and maximum. So suppose I have given this maximum elevation 3000 and the name of this variable is elevation. Okay. So map.addLayer function takes about five kind of parameter. So first parameter is the name of the object that we want to add to the layer. Second thing is the visualization parameter. Visualization parameter stands for what is the minimum value, maximum value. Then the name of the variable which we want to display. Then shown whether we want to display it or no. It means it could be 0 or it could be 1. And then the opacity, at what transparency we want to show this layer. Okay, so all these things could be given, and if you are not providing this, then it will take its default value. So the details is given here. Name is optional, shown is optional, opacity is also optional, visualization parameter is also optional, but this e object is compulsory. Otherwise, what it will display? Unless and until you write the name of the variable, nothing will be displayed. So we will type the name of the variable and some visualization parameter and the name. After clicking on run, you will see the elevation of whole world. SRTM data for whole world is displayed. Suppose you want to go to India. So just by writing these two lines, this three lines of code, you are able to get the elevation of anywhere on the place of Earth. You will just click on this inspector here, and clicking it anywhere will give you the information about the elevation. See, I'm clicking. Suppose
Hello.
I yes sir. Yeah.
Hello.
Hello.
Yes, sir. Sir, I have a query. Sorry to interrupt
Yes.
you, sir.
Yeah. Yeah. Please.
Sir,
Please.
so how you hide these two lines, green one,
Okay. Okay.
three or
Okay.
four?
Oh. Acha, okay. Okay. Okay.
Yes.
Before telling that, I will tell you some few shortcuts. You can visit here this general shortcut. There are a lot of shortcut that is given that you can use in this interface. So if you will go through this, you will get to know. So the shortcut which I was using is clicking control and this backslash. This backslash is used to highlight any line. And if you are selecting more than one line, you can just select more than one line, and you will click on control and backslash. So this whole line will get commented. Okay, just clicking at it again, it will just go away. So it is like this, control and backslash. Okay, so in order to comment any line, we use backslash. Okay, and there is one more shortcut. Suppose you have written some code and you want to know what are the variable, what are the parameter that is given in this function, that this map.addLayer function, what are the parameter that is given. So we will click on control and spacebar. This control and spacebar will open this document window, and inside this window you can see what are the things that we pass in this function. We pass e object, we pass visualization parameter, we pass name, we pass whether we want to show it or not, and we pass the opacity. One by one, I will go through all
Sir,
this thing was.
after hiding these three or four line means when it will run, then it will not execute during this
Yes,
code.
yes, yes. This comment
Oh,
line means that this line will not be executed. Okay.
okay. Okay.
Oh,
Thank you, sir.
and if you want to execute this line, then we have to remove this comment. Okay, it is as simple as that. So just by writing this three line, we can always do cut and paste, copy and paste in this whole code editor. This code editor is very simple. It uses all your commands that you use in your Word, that kind of. So see, here just by writing this three line of code, the first line is for calling that imagery, the second line is for which elevation band we are using, and the third line is to add that layer. Just using this three line, we get to know the elevation of anywhere on this place of Earth using SRTM dataset. And by clicking on this inspector, we will get to know the elevation of the point. Suppose you want to know the elevation of Jaipur. So I will search here Jaipur. Okay, and I will just click it here, and it will give me some average elevation of 432. It gives me the elevation of the pixel on which I am clicking. So the nearby pixel are having 433, some are having 429, and you could see here one layer panel is there. Whatever name that we have written here, that name will be displayed here. Okay, and we can just turn it off and turn it on. Secondary thing that we can do is this slider. Using this slider, we can increase or decrease the transparency. Increase or decrease the transparency. And then suppose you want to change the base map, so we'll click on satellite. This will give me the base map of satellite, and this will give me the base map of normal uh, Google Earth. And if I will click on terrain, then this will give me the terrain base map. Okay, so just by using all these commands, just the simple clicking and clicking off, we can just turn on the layer and turn off the layer. And here is the slider. So this slider is nothing but the opacity. We can also provide this turning off and on feature here. That shown. If I type it here 0, that and if I will run it here, then this layer will be off by default. It will be off by default, and on clicking that layer will come. Okay, because we know that in the map dot add layer, the fourth parameter is shown. So if I click, if I will type 0, then it will not be shown, and if I will type it here 1, then it will be shown on clicking on run, by clicking on run. So see, this is the thing. Okay, and then after that we have the transparency value, that opacity value. We can, if I'm tapping it here 0.5, then my opacity will be 50% on clicking. And see, the slider is set and in the middle. We can even change the opacity just by sliding it here. Also, now suppose if I don't give this visualization parameter, instead I just pass it a blank. So what this Earth Engine will do, by own, it will display whole result in the grayscale value. See, it is just like in a form of a grayscale with all the values are giving in a form of a gray. But in order to have some proper visualization, we provide some visualization parameter. So if I'm supposing, if I'm typing it here 1000, so all the elevation more than 1000 will be displayed in white, and less than 0 will be displayed in black. Means 0 to 1000 will be in the middle, and more than 1000 will be in white. Suppose this China part or this Nepal part, if I'm clicking, since it is more than 1000, it is around 4900, so it is being displayed in white. See, it is displayed in white, while here if it is black, that means it is less than 1000. Okay, we can even provide some palette also, means some color palette. So how we can do this? We can go to this setting button. Okay, and here you can see there is option of giving some gamma stretching also, and there is one option for giving palette. So we will click on this palette, and we will click on this plus button. So this plus button, after clicking this plus button, we will try to give the palette from low to max, means from minimum to maximum. So for the low elevated value, suppose I'm giving it to be green. Okay, some dark green. I will select this color, and I will click OK. Then I will click one more time, and for some middle value, I'm giving it to be yellow. Okay, so I'll click on yellow, and I will click on OK. Then for high value, I'm giving it to be red. So this red I will click, and this I will give it OK. And then I will click on apply. When I will click on apply, what will happen? The whole image will be classified into three classes. One will have green, some will have yellow, and other will have red. And how it is classifying? It is classifying this range, this 0 to 2000 rate. It is classifying into three classes. Means more than 1000, it will give to be the color of red. Close to 0, it will give color as green. And close to the middle part, means suppose if it is 5000, if it is around 5000, if it is around 500, then it will give to be color as yellow. Okay, we can even change this. Suppose if you type it here 4000, then this 0 to 4000 range will be classified into three classes. Now it will be like this, that more than 4000 it will be in red, somewhere about 2000 it will be in yellow, and near about 0 it will be in green, 0 to 100 or somewhere in between. We can even import this visualization parameter by clicking on this import button. Just by clicking, you can see a variable is created. The name is image param, and and we can just copy this variable name, and in this visualization part we can just paste it here. And just by doing this, we now don't have to use this setting button. Instead, we have directly called upon that image visualization parameter here, and this whole image is being displayed in this three color. See, and if you will look on the details of this visualization parameter, so it is taking band as elevation, maximum values 4000, minimum value 0, opacity 1, and this palette it is taking this three color. One is for green, second is for yellow, and third is for red. So likewise, we can do the visualization of elevation band of any location. Now the second important question comes, key how to export. Suppose we have some place of interest, or we have some kind of shapefile, and if we want to export the DEM of our region. So the DEM downloading process, you know that one thing is that you go to USGS website, and there you log in, and there you select your region of interest, and then you select the name of the band of SRTM, and then you download it there. But all that process take a lot of time. Using this interface, only once you have to keep one code ready, and you have to just change your place of interest depending upon your geometry. You will get the you will get the SRTM image of that file. So how to do that? We will use the code of export. What is that code? That code is export dot image to drive. Export image to drive. Using this function, we can easily export our image. So before exporting, we first have to select the region of interest. Suppose you want to export the DEM of Jaipur. So I will search here Jaipur. Then using this feature button or this geometry button, I will draw a rectangle. I will click it here. This geometry will come. I will draw a rectangle over Jaipur. Okay. So after clicking, you will see that there is one variable whose name is geometry, which is a polygon having 4 vertices that is being created. I can give it the name to be AOI, that means area of interest. Any variable name I can give it. Why I am giving this polygon? So that I have to, means I don't want to download whole of the DEM. Means I don't want to download the whole tile. I just want to download the digital elevation model of my region of interest. For this, I have created a region of interest, and then I will use this function export image to drive. And inside this, as I have told you earlier, using control and spacebar. After clicking control and spacebar, we get to know what are the things that is passed in this image to drive function, and there are something which are optional, and there are something which is compulsory. So if you will read this, that image, the arguments it takes is first of all it is the image. So what image we want to export? We want to export the image of DEM, that means SRTM DEM. So that will go in the name of the image. Then at the place of description, We will type the name ki by which name you want to save that file. The whole file will go to your Google Drive. So it should have some name. That name is been given in the description panel. Like you can give it to be SRTM Dam of Jaipur, SRTM Dam underscore Jaipur. That thing is given, and we should not use any spaces while giving that thing. By default, it will go to my export image task. But here we can change it. Then this description is optional. Second, then the name of the folder. Suppose you have a dedicated folder of Google Earth Engine in your drive. So in that drive, you can give the name of the you can just type the name of the folder here. It could be GEE or it could be export data. Whatever the name of that folder is there, you have to just type the name of the folder, and that image will be exported in that folder. Then if you want to add some kind of prefix, means the name of the place or something, some letter or some number, you can do that. But that is also optional. Then the dimension of that image, if you want to specify the width and height, that could be given, but that is also optional. That is not compulsory. Then this region, if what region you want to export. This, however, it is optional, but this is very important that this should be given. Until and unless you will give the region of interest, it will try to export all the imagery that is shown in your visualization panel. So we don't want all the imagery. We only want the imagery of our place of interest. So we will type the name of the region, and here the name of the region is AOI, area of interest. Okay. Then the name of the scale, the scale means at what scale that imagery is. So we know that this NASA dam is having is at a scale of 30 meter. So we will give the value of scale to be 30 meter. If you will not provide that scale, then it will take default as 1000. But since we know the scale, so we will give it the value to be 30. Okay. Then this CRS is coordinate that this what's it, reference system. That means whether it is WGS or whether it is your UTM zone. So you can even specify your coordinate reference system to be used. You can even do some transformation. Suppose if it is by default, if it is in some other projection and you want to transform it to your UTM projection, that part could also be given here. Then comes the value of maximum pixels. What this maximum pixel does? Suppose you want to export the dam of very larger area of interest, but by default Google Earth Engine do not support do not support Google Earth Engine will not support you to export a large image. Suppose you want to export image for whole India, but that is not possible. The only possible is that you if the Google Earth Engine allows to export 2 to the power 32 pixels. So more than 2 to the power 32 pixel is not allowed. And by default, it only allows 10,000 to 1 lakh pixel. So if you want to increase its default value, we provide maximum pixel, and this maximum pixel we can provide up to 2 to the power 32, not more than that. So it gives to the power 10 to the power 8. It supports by default, it gives to the 10 to the power 8, but we can increase up to 10 to the power 10 or 10 to the power 12. That means 2 to the power 32, but not more than that. And then there are some shared size also. If you want to means if you want to resample that region, or if you want to export in the form of tile, that thing could be given, but that is not required. And then file dimension also. That means what is the means dimension means just the whether you want to give it in the form of square shape, or you want to provide some kind of width or height. Then skip empty tiles. This is required. Suppose if your region is having some masked pixel, and if you want to export that also, so in that case you have to specify that skip empty tile. If you don't want to use that mask portion, that you have to specify this. And then the file format. The default file format for any raster image is GeoTIFF. So whether you will give or not, it will take by default as GeoTIFF. And there is one more option to give in the form of TFR. The TFR is tensor flow record. Suppose you want to do some kind of machine learning in your Google Cloud. So you can export in a file format of TensorFlow, and that file format, if you are exporting in TensorFlow record, that you can easily import in your Google Cloud, and you can do some kind of machine learning and other artificial intelligence work there. And this is the some kind of format option. If you want to give some kind of string, whether you want to give up to two decimal places, or you, if you want to give some other format options, like at how many decimal place that suppose if you want to, if you are exporting with date, that what should be the format of the date, whether it should be DDMMYY, or it should be just MMYY, or it should be in the form of YYYY, means only in the form of year. That kind of format option is could be given, but that is also not much required. So the things that is required here that we will be using will be, first of all, will be the image. So before using that, after this small bracket, we will provide a curly braces, and then we will give the name of the image. So the name of the image will be there. The name of the image will be elevation, ELE. Okay, not in inverted. It should be the name like this. Then the description. We will give the description after colon. We will give the description like SRTM underscore Jaipur. Okay. Then suppose if we have some folder name, then we will give a name of a folder. If you don't have a folder name, then whatever name that you will specify, it will create a folder with the name of this. Then this file name prefix is not required, dimension is not required, region is important. Region is required, and we will provide here as A of I, area of interest, the variable that we have created, this polygon. Then comes the scale. Scale, we know the scale is 30. Then this coordinate system, by default it will take WGS, so no need to worry. Maximum pixel we can specify to be 1E10. We can provide up to 2 to the power 32. Rest all things is, these things are not required. We will close that curly braces, and this code is complete. This export image to drive is complete. Okay. And before proceeding to that, we can even do one thing, like we can use the function clip, and using that function we can clip this elevation to our region of interest. Means we will write ele.clip, and then inside we can type AOI. What this will do, I am just hiding this first of all. What this clipping will do, this clipping will clip my dem to my region of interest, my area of interest, and the whole, what it was happening before that, dem for whole region it was giving. Now this whole region is in the color of green, as I know key it is in 433, means less than 500 or less than 2000, depending upon this visualization parameter, the color is coming. So now you could see that this dem value is coming only for my region, and for the whole region the dem is masked. Anywhere, if now I will click, then it will say that there is no unmasked pixel. That means the whole region is being masked. Okay, and only my region of interest is being shown here. Now if I just want to export this, I will use this command and ele.clip. I can even clip it here, so that elevation of my region of interest, or this dem or the SRTM image of this region of interest is being exported. Now I will run. After clicking on run, you will see that there is a task window. In the task window, the name that we have given, the description, that name has come, SRTM Jaipur. I have to click run once again here. Now it is asking some parameter. Some parameters are already filled. It is asking for coordinate reference system. If you want to provide, then it is fine. Otherwise, if you want to give it to be UTM, then you can provide here like EPSG. For UTM 43, it is 32643. And You can click on run. If you will don't provide, then it will go by default in WWGS system, means degree decimal system. If you provide in UTM, then it will go in the form of meter. And just clicking on run, depending upon your area of interest, how much that area is, and depending upon your internet speed, it will export this image to your drive. So it will take some time. Okay, so if you have any doubt up to this place, then please ask anything if you want to ask. Meanwhile, the image is being exported.
Any
Can
questions?
we overlay the shape file of my region of interest?
Yes, sir. Yes, sir. If you want to do with the shapefile, I will tell in the next step. So you could see this the region of interest, it gets exported within less than 1 minute. Your whole DEM is being exported. So you will go to open in the drive. Okay, and you can see here in the name of, I have already exported some other task also. So this is SRTM Jaipur. Okay. So just see here, the SRTM Jaipur is here. I have a lot of data there. I will type it here as SRTM Jaipur. This image. So this is the image. I will download it here. I will open QGIS, some ArcGIS. Okay, here QGIS will take some time. As you all know that software work takes a lot of time. So all this part, if you are just processing the whole image on the Google Earth Engine itself, that is a very better option as compared to the process in our software. Even the software opening time is very good. So all these advantages are being taken care of. Suppose if you want to work the same thing on using our software, then first we have to download the whole type, and then using the shapefile of our region, we would have to clip it on ArcGIS or QGIS. But whole that clipping part, that downloading part, is all been taken care of by this Google Earth Engine. Okay, and just the visualization part, you can use it. You can see it in our QGIS interface. So see this whole elevation is been shown here. It is from 0 to 599, and you can change the symbology here. So you could see the elevation of that region of interest has been exported. How to do it for our shapefile? So for that, first of all, you need to know how to import your shapefile. Okay. So in order to import your shapefile, you have to go to this asset panel. Okay. In this asset panel, you have to click on new, and then there are various options. The option to upload your own geotiff. Suppose you have some high resolution imaging, so you can export it. You can import it here, and you can even import your shape files. And you have to remember, this four format is only required: the .shp, .shx, .dbf, and .prg, or the zip of these four data. So we will click on sorry, we will click on shapefile. Then we will click on the source, and suppose we have some shapefile of any region. I have to search for some shapefile. Mm, Shapefile. Yeah. If you have any shapefile, you can share it with me. Otherwise, I have to search for my own shapefile. Suppose I have some study area shapefile. So as you know, all files are not required. We will just upload SHP, SPN, PRG, CBF, okay, CPGs. See, since whenever if you upload any wrong file, it will say that it should have all the relevant files. So here I must be missing some file. I'm missing .shx file. So it is giving me error. So what I have to do? I have to again all the file I have to upload it here. This is my SHX. You have to remember the .sbx is not supported. So we don't have to upload this .sbx. Now see, the study area is uploaded and I will click on upload. So depending upon my area, how much big it is, or my region and my internet speed, that part will be submitted, and that will come in a form of an asset here. Here it will take some time. It will try to convert it in its own projection system, Google Earth Engine projection system. It will take some time, and then it will come here. I've already exported a lot of shapefile. You could see here a lot of shapefile I have already uploaded here. So this will come by the name of study area. So depending upon my region of interest, it will take some time. Meanwhile, if you have some other doubt, then you can please tell me.
Sir, I have a problem, sir.
Yes, please.
Sir, I'm uploading. Sir, I have a shapefile of UP. I'm
Okay.
uploading it, but it's not processing.
What is the error that it is giving?
So let me check.
See, it gets uploaded. You have to remember it does not support all the files. So better you give .shp, .shx, .dbf, and .prj. Only this 4 file you have to provide.
Okay,
UP if you are providing that shape file, and the name you should also remember it should not have any space or something.
okay. I'm trying
Okay,
it.
so you just check on if only if you are uploading this 4 file, it will process, and it will take some time since the UP area is a big area, so it might take some time, but error will not come. It will surely get uploaded. See here, I have uploaded that shape file in less than 1 minute. That shape file has been uploaded here, and the name of I have given it to be study area, so it will come here by the name of study area. See here. So just by clicking this small arrow, I can import it in my script. And after clicking on import, it will come by the name of table. Okay. So I will delete this AOI and now I will rename this table to be my AOI. So what will happen? After running this code, that will go to my area of interest. So before that, I can also set my center. What I can type, I will type map.center, center object, and then I will type my AOI. What this line will do, this line will take this whole user interface, this bottom window to my AOI. Just by clicking my and comma, I can even give some zoom level. At what level it should zoom. Just by clicking on run, you will see this was my area of interest. Suppose I'm giving zoom level. So this was my shape. It's a kind of horizontal shape. This is for the Asan River in Dehradun. So this was the shapefile, so it gets uploaded and the dem of this area is being shown here. And on clicking on its value will also get displayed. It is 576 and something. Okay, so my shapefile has been uploaded and the whole region is been shown to my area of interest. And after clicking this task, this run, I will change the name Change the name to study area. Again, I have to run. See, the name of the task, it will come as RTM study area. And after clicking on run, the dem of my this area of interest will be downloaded. So similarly, you can upload your area of interest and you can download. But remember, sir, if you are working on UP, so that area is very big. So it might happen that it may not process the whole dem of that area. It might happen. It will not export the whole region. You can try to increase your maximum pixel. You can increase it up to 1e12. So it might work for UP also. If you have any other doubt, then please ask.
Sir, I think I'm not downloading it, but it should be shown on
Yes.
the screen at
Yes,
least.
yes, yes. Okay, okay. For that, you have to upload it. So, was that working? Was it got uploaded?
Sir, now it's in the script
In
area, but
okay, okay. Huh.
not processing now. Can
Why
I
it is
share
not?
my screen, sir?
Yes, yeah. Please, you can share your screen. Uh, yes, please share your screen. I think it is uploaded here, and you have called it here by the name table. So you have to change the name of table to be AOI. See here, nothing is AOI. The error is given, AOI is not defined. So what you have to do, you have to click on table. Either you can give the name of AOI as table 3, or you can change the name of table 3 to be AOI. Anything you can do. Click on that variable, yes, and type it here AOI, yes. Just click on run. This Jaipur is not defined. This Jaipur you have to keep it in inverted comma. This Jaipur name, the name of the description should be in inverted comma. Otherwise, it will treat it to be a variable name. This folder name should also be in the inverted comma. You have to provide region also. Or you can just hide this export command. Visualization will be done. You can just hide, select, control backspace, okay. And after yes, since you have not clipped to your area of interest, so it will give your elevation for the whole region. So instead, uh, after this ELE, you can type dot clip in the line number 3. Yeah, this whole line you can copy it in the line number 3 also. Dot clip, not dot clip. The dot clip comma AOI, you have to copy it in the line number 3 in that map dot add layer. From elevation. No, not here. Just after ELE. Yes. Type it ELE dot clip. ELE dot clip, and in the bracket you have to type AOI. Small bracket AOI. Yes. Now if you run, it will go to UP. It will go to UP. You have to take your screen to UP. You can write one line map dot center object, or you can directly go to map dot capital M. Map dot center object. Map dot center object. You have to type the map M should be capital. Map dot center. And then click control and spacebar. So center object it is written, and in the bracket you have to type AOI. AOI. Yes. Now you can click on run. Was that UP file correct? Your shapefile, I think,
Yes,
was,
all correct, sir.
but your
I'm using.
no, but I think your AOI is not correct because it will come towards UP. I will I will show you in my screen for UP also. Okay.
Okay, okay, okay.
No, okay. Okay. I will show you for UP also. The thing that you were missing before that, it was coming by the name table, so you have to give that name table. So since I have already uploaded here shapefile of whole of the India, so I can show you for UP also how it will look. Like suppose India new state I will import, and from that table I can filter it to my region of interest. Table dot filter, I can use dot filter ee dot filter dot eq, the filter equal to, and I have to look the attribute of my shapefile. So since I have uploaded for whole India all the states name, so I have to select for the state, I have to select Uttar Pradesh. So what I will give it here, like name st name comma Uttar Pradesh. So this will be my AOI. I will delete this original AOI, and when I will click on run, see it will come to UP. Everything is coming green because in the image visualization parameter we have provided minimum maximum to be 4000. So max I can provide 2000. It will come in grayscale. So if it is not visible, then I will remove this also. See the dem for whole UP is been displayed here. Likewise, you can just, if your shapefile is correct, then everything will be fine. You have to upload correct shapefile with all the layers, all that 4 layers that is being said here. If that thing is correct, .shp, .sv, .dbf, and .prg, if these 4 things are correct, then your shapefile will be displayed here. See here, suppose I just the same thing if I have to do for Uttarakhand, I will type it here, Uttarakhand. Since I have uploaded for whole of the state, so I can do it for any state. The visualization parameter, if I can copy this here, you will see a good visualization for this part. See, this is the dem for Uttarakhand. Similarly, we can type for any state. Any other doubt? And just in the task layer that name will come, and if I will click on run, the dem for this whole region will be downloaded. Likewise, you can do. Do you have any other doubt?
No, sir. No, sir. I will
Okay.
practice on this.
So yes, I hope that you just practice on this. You will try to check what are the errors that is covering. If you are getting some doubt, you can type on the Google and search how to remove this error. All these things, and you can even go to their documentation page, their user guide page. You can go and you can even learn there. A lot of code is been given there that you can just simply try on. Okay, so moving further. Now suppose you want to go. Now you want to analyze the slope of my region. So the Google has some inbuilt command for some terrain processing. If you run terrain, so you can see there are some slope value, hillshade value, hill shadow value. All these things are already provided here. So suppose you want to know the slope of my region, of this Uttarakhand region. So what I will type the name a variable slope, and then I will type terrain dot slope, and inside this slope I will provide the name of that variable which is storing the value of my elevation. So here it was ELE. So I will type it here elevate slope, and now I will display. How I will display it here? I will display it by using the same line which I was using for them, but instead of elevation, I will type it here slope, and that should be in the same. Okay. Now if I will run, so now there will be sorry, the name should also be changed here. Slope. Okay, there is some error. Available band name slope.
Hello.
Okay,
Hello, sir.
yes, yes,
Sir,
yes,
I have some basic
yes, yes,
question.
yes, yes.
Sir, can you please tell me which part of this coding as a input and which part on which line consider as a output command?
Okay, all the
Yes, sir.
lines that you are typing with the name of variable like var aoi, var dataset, var ele, all these are supposed to be input pipe input things. Means you are providing some name of the variable which you are taking as an input. Suppose you want to take input as, here you are taking input the value of srtm elevation. So all these are input, and output will have two lines especially. Either you can map.add layer. Mostly the map.add layer gives me the output. So what this is giving? This is giving me the display image. The all the image that I am processing in the input lines, in the processing lines. Then map.add layer will give me the output. Mean map.add layer will give me the output in the form of a visualization in my bottom panel. Okay, and we can
Okay.
sometimes you can also use this print command. What this print will do? This print will give me the output in a form of in a console window, and here it will give me the output in the form of the name of the image. What are the image that I have used, how many, what is the name of the band name, what are the properties, what is the description, date, and everything. So mainly by this two form we get the value of output in the form of map.add layer or in the form of a print. Also one more output you can say is in the form of this export. This export, what this is doing, this is taking all your process data, and it will try to export the data that you have processed in a form of a shape file, or it could be in a form of a TIFF file, and that gets exported to your Google Drive. So this is the this could you can consider to be output. This print could be considered to be an output command, and this map.add layer could be considered to be an output command. Rest all could be considered to be either the processing command or the input command. Okay.
Okay. Thank you, sir.
Okay. Now if you want to now if you want to do the now if you want to get the slope of an area, so we will use simply this inbuilt function eTerrain.slope, and inside this I will use this variable elevation ele, and then I will try to visualize it. To visualize, I will write map.add here, and I can even give, give some visualization parameter. Here I have kept it to be empty. I can change it later, and the name of the variable. So on clicking on this run, since there is no visualization parameter given, you could see it is empty. So it will come in grayscale. And here by the name of slope, I have given the name as slope. So it will come as slope. So now you could see the slope of my slope, and since I have not clipped, I think no, I have clipped, so it will give me the slope of my area of interest. So if my area of interest was Uttarakhand, then whole slope of this area is given. So I don't have to process all this thing in my QGIS or in ArcGIS. I can directly process it here, and I will simply export my slope file also, and the export command will be the same. I will use this same code. I will copy. I will paste it here, and instead of this elevation, I can give slope. And
So is slope in degrees or in percentage?
the slope is in degrees, and you can even check it here just by clicking on inspector. You can click it anywhere. So see the slope value 21.48. Okay, sir. So it is in the form of a degree. Okay, you can even click control and space bar after this slope command, and you will get to know the details. It will calculate slope in degree from terrain depth. Local gradient is computed using 4 connected neighborhood. All the principle of slope, how the slope is calculated, that is given here, and what the input it takes. It takes input as elevation in meters.
Thank
Okay,
you.
sir?
Thank you, sir.
Okay, sir. Now this is the my slope area, and we have already learned how to change the visualization. We can click on this setting button. We will go to this palette, and simply we can change the low slope area. Uh, suppose we can give to be green, and some midwise we can give to be yellow. Depending upon your interest, you can give more than 3 or more than 4. As many as you wish, you can give your palette. Okay, and after clicking on apply, see the whole region it gets into 4 parts. You can even change some color, like, and this slope, suppose more than we can ever give here minimum maximum 0 to suppose 50. More than 50 it will come in. Suppose I want to give it in red, it will come like this. So when I will zoom it, it will slow. The high slope area is in red, some are in blue. Likewise you can visualize. See, all the snow covered area or the hilly parts of Uttarakhand could be seen in the form of red color. So likewise you can do the visualization also. This visualization does not change its value. It is just for the visualization. Means this color palette is just for the visualization. It does not mean that we are changing some value. All the default value will be stored, and if you are exporting, that image will be exported in grayscale only. And you can in QGIS you can change the visualization color after exporting. So similarly you can export the slope also. After clicking on run, in the task it will come slope study area, and the original it was dam. So dam and slope you can directly export it. So these are the basic things that you can do with the help of a dam. Similarly, if you want to do some processing using some landscape dataset or some Sentinel dataset, in the morning session, Vaibhav might have told you something, how to visualize the time series and all. If you want to export your Landsat data also, that thing also I'm going to tell you now. So if you have any doubt up to this part, then please tell me. Any kind of doubt, small doubt, big doubt, whatever doubt you have, please tell me here. Okay, so I think all these things are clear. It is very simple. It just looks like big line, 15, 16 code, simple line of code, but it is very simple. If you will just read, then you will get to know it is very simple. The data set, this elevation variable, and how to add that layer center object, and this export. This export will remain same for every code. All this time will remain same for every code. Okay.
Hello.
Hi, hello.
Hello, sir. I have a
Yes, yes.
minor question.
Yes,
Sir,
yes.
as we are going forward in this lecture, we are
Mhm.
adding in between anything, as I presuming. But how can separate the coding? This part for this function, and next part is this function.
You want to separate here only.
Yes,
Uh,
sir. As we are increasing code, but we cannot separate which part is executing for which particular function.
Acha, so no,
Which actually we
directly.
are adding.
Yes, yes. Okay, fine. So
Sir, you
no,
got
actually,
me.
yes. Actually, what
Okay.
this Earth Engine interface does na, it try to run all the lines that you have written, And suppose for your understanding, what you can do, you can simply write some lines by creating slash, and here you can write this part is for elevation. Manually you can do this, and after this and that bottom part here, it starts for slope. So you can just paste it here, the same line, and you can just click it to be slope. But since it is not commented, so it will be executed. So in order to stop its execution, you have to press Control and backslash. And likewise, you can just highlight this part, and you can not highlight, means you have to comment the other part, and you have to click on run. If you do like this, then this will work only for elevation. Okay, and if you will highlight comment this part, since that part is required here, and if you will uncommenting the bottom part, then this will work for slope only. So likewise, you can break, or you can click a new, you can create a new file and you can just copy it there. You can create a new file by the name of slope, and there you can just copy this whole code, and you can just paste it there. Slope. Small. You just click on here, and it will be saved there. So likewise, you can save it here. Either you create a separate file, or in the same file you just inundate. I think that code is lost. Okay, no problem. So now we will try to learn for some indices generation like NDWI or NDVI, and we will try to export it also. Okay, so suppose here I have written few lines of code in the previously only. Okay, I will hide this part. That part is not required. I will go one by one. I think Vaibhav might have told you. Okay. So now we will learn something about indices generation. That means how to generate some kind of indices like NDVI or NDWI using that using Landsat imagery. Okay. So in order to do that, first of all, what we will do here, we will type it here, the name of the imagery. Suppose I want to work upon Landsat. So I will type it here, Landsat 8. Suppose I want to work on recent Landsat. So the recent Landsat is Landsat 8. And you will see there are a lot of options. Landsat tier 1, tier 2, collection 1, raw scenes, OLI raw scene. So what we will select, we will work on Landsat 8 TOA, this top of atmosphere, and collection 1 TOA. Tier 1 TOA. This thing we will use. Because why we are using this, it has already removed all the haze from that Landsat imagery. All the pre-processing that we do after downloading it from USGS, and we do all the pre-processing like haze correction and some terrain correction and all that correction has been done already. This Google Earth Engine interface, this Google people, this NASA people have already corrected all the Landsat imagery, and then they have uploaded in this platform in the form of this TOA reflectance. Okay, so we will call this. Since you can see here, I have already called this by the name of L8. So when we will click on import, it will come by the name of image collection because it has a lot of imagery. So it is an image collection. So I will give it name to be L8. L8 is just for Landsat 8. Okay. So I will call this imagery and I will give it to be name as L8. Now what I will do, I will try to filter for my region of interest or for my date of interest. So suppose I want to work for my filter date for the year 2021. And since we know that cloud-free imageries are generally available during the month of March, February, or during the month of October, November, so we will try to limit our date in that zone. Okay, so I have created a sorry, I have created a variable name filtered in which I am calling that landscape date collection, and then using this command dot filter date, I will try to filter for my region of for my date of interest. So I have created for the month of March. Okay, from 1st March to 30th March. Then what I am giving, I am trying to filter the clouds. I am calling that imagery only which has cloud cover less than 10. So if you have to see it carefully, that we have to write it filter metadata m capital, then this cloud cover in inverted comma, then comma, then less than command, and then 10 means I am just telling Earth Engine that from all the images of this land set in this date of in the in this date of interest, just filter all the cloud which has all the imagery which has cloud cover more than 10%. So this will do that work. Now I have created another imagery by another variable by the name of image, in which what I am doing, I am just calling the median of this imagery. Suppose this in this date there could be more than one imagery. If I will click on print filter, so you will see here in the console panel all the imagery that are present here in this image collection for this date having cloud cover less than 10. See, it will give me a lot of, there will be a lot of collection. So there are 4,773 elements. Means for all over the world on this date, on this date range, there are more than 4,000 imageries, 4,773 imageries. So, but I am not interested for whole of the world. I only want to work for my region of interest. So what can I do? I can type it here as filtered bounds. Filter bounds will what this will do? It will bring all the tiles that is near my region of interest. So here first of all I will okay. Uh, I have this, my region of interest is this point, I think. Okay, I will just delete this table also. Okay, first of all I will select my region of interest. So suppose my region of interest is Jaipur. Okay, so I will create a point here, Jaipur. I will name this to be point. Okay, so I have created a point here on my location of interest, and then what I will do, I will do filter bound to my point. So all the image collection table is not defined. Okay, I will create one table also, means one geometry also. Suppose if you have done some wrong in this feature, suppose you want to delete some feature, so you will select this hand and you will click on this feature, and just clicking on delete will remove that part. Suppose I want to add one more layer by the name of table, and I will create a table means a polygon. I will create a polygon by the name, suppose I can give it to be A1. So now first of all you will see what I am doing. I am calling this landscape collection for my filter date of interest for cloud cover less than 10, and I have also given some filter bounds. The filter bound is nothing but my region of interest. I will just remove this Okay. Okay, all the code is good. Okay. So now if you will see this image collection from 4773, it has reduced to one element, because in my region of interest only one imagery is there in this date range. Previously, if I was not when I was not doing this filter bound, what it was displaying that it was more than 4000, because for all over the world in that date range there are a lot of images and there are more than 4000 images. So it is taking time also to compute that. See, it was 4773, but as soon as I have given the filter bound, so now that whole imagery is only reduced to one, because only one image is present, and that you can even see clicking on this feature. You can see the date also here. This is for 7 March 2021. So only one imagery which has got cloud cover less than 10 is for the date of 7 March 2021. And we can even add that imagery, map dot add layer, and click on image. This image is here, and as the relation parameter was not set, we can even set the relation parameter. Suppose I want to go for FCC, so I will type 543 here and apply. See here, the FCC imagery is for my Jaipur region. The whole tile is being displayed here. So this is my Landsat tile for that March month, and this is the FCC. I can even change some gamma relation parameter and make it to be more bright or dark. Even I can specify this this thing, the minimum maximum value, and I can make it more bright. Finally, I can import this visualization and use it in my visualization part here. And just the name we can give FCC Landsat. Okay. So here FCC Landsat 8 name has come, and this is my Landsat imagery for my area of interest. Okay. So just by writing this line, only this 3-4 line, this is a single line. I have just removed left enter. One line is this, second line is this variable median, and the third line is add there. Just by writing this 3 line, I can call Landsat imagery of any location. Means here I have given the location of my point, this point. This was the point. So whatever the tile that is present near to this point, that will come, and I can even shift this point to anywhere, and the imagery will come according to that point. The same. I'll click it here. If I shift it to Agra, then you can see the tile for Agra will come. Okay. So depending upon my point, I can get the Landsat imagery of any location. Okay. Now suppose I want to work for its NDVI. NDVI stands for Normalized Difference Vegetation Index. That gives me information about the vegetation of a place. I am taking it back to Jaipur. If the NDVI is high, that means the region has got a lot of vegetation. That vegetation cover is nice. Okay. So how we can do? The best thing that we can do here is by creating a simple function. We can create a simple function by the name of normalize difference. We can use the function inbuilt function normalize difference. So how we will create a function? We will name a variable. Suppose variable name is add ndvi is equal to some function name in which I will pass some imagery. And what this function will do inside this square curly bracket, what this will do, it will create a variable name ndvi, and it will take that image, whatever image that I am passing, and it will compute the normalized difference. Normalized difference function will do, it will take the value of 5 minus 4, if whatever band that I am giving here, band 5 and band 4, it will try to find the normalized difference. Means it will do band 5 minus band 4 upon band 5 plus band 4. That ndvi, that normalized difference function, this will do 5 minus 4 upon 5 plus 4, and that thing I am renaming it to be ndvi. Okay, the name will be given. So whatever it will return in a form of an ndvi. The name will be changed to ndvi. So what I will write it here, return image, and I will add this band which has computed the ndvi. I will add this band. So this small function will compute the normalized difference of my imagery, and it will add that ndvi band. Okay. Now for a single image we can test this. So how to test this? Suppose I am writing it to be ndvi1. Okay. So what I am saying, my this variable will take this function image, and what is this image? This image is nothing but the image which I have used, the median imagery. It will take the median imagery. From that median imagery, it will select ndvi. Why it is selecting ndvi? Because I have renamed the name. I have added this ndvi band. So I want to select that band. I want to select that ndvi band. So what I will passing that function, this function, and I am selecting this ndvi. And I have provided some parameter like minimum value minus 1, maximum value plus 1. As you know, ndvi ranges from minus 1 to plus 1, and I have given some visualization parameter like the lower it should give to be blue, the higher it can give to be green, and the middle portion it can give to be white. Okay, whatever visualization parameter you can provide it in this palette also. Okay, and then if you want to visualize the output, we have to, if I want to visualize, then we can go to map.addLayer ndvi.clip AOI. The same function that we have used for dem. That same thing I am calling this variable, and I am clipping to my area of interest, and ndvi parameter is nothing but this minimum maximum value, and the name will come as ndvi image. So on clicking, you will see first FCC and then this ndvi. And why it is not showing for whole? Because I have clipped. If I will not clip it here, then you can even see it for your whole. Suppose if I am not clipping, then that whole tile and ndvi will be computed. See, the ndvi for whole value is computed. And now if you want to check what is the value, I will click on inspector and I will click anywhere. So it will give me the information about this FCC landscape imagery, all the band information, and then for this ndvi image, it will give me the value of ndvi. So here, since it is more greener, so its value will be high. And suppose if there are some water bodies, then ndvi will be less for that area. Suppose there are some water body here. So if I will click it here, you could see it depends upon this how much. Here it is land, here it is water. No water in Jaipur. Okay, suppose I can shift this to somewhere here where there is a water. I will zoom it. I zoom it to some water. DJ. So I click it here. Then the NDVI is low. Dense water. If very so NDVI will have very less value in here. Suppose it is Ganga River. See here, it will be in negative. Okay, and NDVI has higher value during in vegetation, and it has very low value in the water body. So NDVI is generally used to identify the vegetation of an area. Okay. Now, if I want to do it for whole image collection, means suppose instead of a single imagery date, which I have already filtered here, the filter date for March and the cloud cover. If I don't want to do this, I want to do the NDVI for whole Landsat collection, whatever date for whatever date it is. So what I will do, I will create a new function with NDVI, and I will call that I will call that image collection Landsat date. Here I have neither given the filter bound nor I have given filter date, nothing. For whole image collection, I want to compute the NDVI. So all the image which is present in this L8 collection, starting from the first date, I mean 2013 to 2022, it will try to compute the NDVI, and I can even map those. So NDVI collection, this NDVI collection you could see, it will be for NDVI for whole world. Since it will be very heavy, so it will take some time. It is taking some time.
Excuse me, sir.
Any doubt, please ask. Meanwhile,
When I write the code to filter the data from the data, so it's so some error.
what is the error? It might be displayed in your console window. What is the error?
It shows unexpected one and or some this type of error. So
You might,
red cross on the
okay, and in the right panel, what it is showing here? There. Please tell me the exact line. What it is written here in that console panel here, right side.
it shows nothing.
It shows nothing.
Yes, sir.
Okay.
When click on the map, when click on the map, so that it show the latitude longitude value
Uh,
and the thing. In error
no,
it
no.
shows on when I click on the error, so it's so unexpected one, and in error 2 it shows some semicolon error, this missing semicolon,
Acha,
this
this thing you are saying this part. Uh, like see this semicolon is I think it is not very much necessary, but here inside every part you have to look carefully that the date range that you have given, it should be inside inverted comma. This comma should be there, then this bracket close should be there, then this cloud cover is in inverted comma, this less than in inverted comma, and this comma temp. And you are clicking on inspector here. And instead of that, you just click on console here. If you click on console here, and then if you run, the name of the error will also show here. He expected something or whatever the error that is displayed, it will display. Suppose if I don't type, if I miss this bracket, then it will say unexpected token somewhere at line number 107. So say this is my line number 107, And since I have missed this bracket, so it was written unexpected token. So likewise, you have to check what the things that is written here. If you can tell me, then I will tell you. I will tell you how to remove that. Otherwise,
Can
if
I
you
share the screen?
yes, hello, yes, you can,
Yes,
you
yes,
can
yes.
share.
I just save my screen.
Yes, please, you can share. Yes, please, share your screen. Yes, please share your screen.
Yes, sir. Hello.
Okay, okay.
Can you
You
see
yes,
my
yes,
screen?
yes. I think your error is after that filter metadata. You have that dot and filter metadata should not have any space.
Okay.
See that filter metadata should come with dot. Yes, just remove that space.
Yes.
Okay, and also remove that space before this filter bound also. Filter bound before that filter bound. Remove that space. Okay. Yes, and one thing more, that point you have to create a point by clicking on this bottom in the screen. This point feature. Your voice is echoing, I think. Just see in the bottom part there is one point line polygon option in the bottom window left side. So you have to create a point. Yes, not here in the bottom visualization window where you are zooming, where there's an option of zoom plus and minus. Bottom part. Yes, here above that there is one point option. There is a hand tool. Yes. This geometry you have to click it somewhere on the screen. You have to click it after selecting that geometry. You have to click it. You can select that point feature instead of this polygon. You can select the first one, the point one. Yes, and then click it somewhere on the screen. Yes, and you have to change the name of this geometry as point. Above in the above panel where you are writing the code, here in the top. Yes, go to that geometry, click on the geometry and type it as point. Okay, now this variable could not be renamed. No, this will be okay. It is done. Now one more thing is that this image visualization parameter you have to just delete it because you have not given any image visualization parameter right now. Na? Mean minimum maximum value you have to define. Otherwise, you can just remove that image with parameter line. Line number five. Line number five. No, not this. Line number five. Yes, the image visualization parameter line. That word that is written image, not the whole part. Just the image visualization parameter variable you have to remove. Okay, and that filter date is also, I think something is missing in that filter date. Some space is there. Also that you have that L8 you have written 18. I think you have to type it there Landset in line number one. Yes, there you have to type Landset because your name of the variable is Landset. Yes. And this filter metadata means I think I is missing. Line number second in filter metadata spelling is wrong. FIL I think. Yes. Filter metadata I think D should be capital or what? I'm confused. No, D should be small. Okay. If it is filter metadata. Fine. Filter metadata. No, there should not be any space. The whole line should be in violet. It should come in violet. M should be small, I think. No, M is capital. D is small. M is capital. D is small. Yes. Now it is coming in violet. Uh, okay. Okay, just click on run once. There are two red cross given. That means you bring all the code in a single line. You bring all the code in a single line. Yes. Yes. And previous line also. Click it before filter metadata. Yes. Okay, fine. Something is missing, guys. Okay, what I am doing, I will share you my code. You just click. I am sharing my code in the chat box, so anyone can use it in their own screen. You just copy this code or just click on this code, and the whole code in which this indices generation is there, that will come. Meanwhile, I am sharing my screen. Okay, is my screen visible?
या
Okay.
सचिन विजिबल। और कितना देर रह गया सचिन?
कब तक है सर टाइम अपने पास?
नहीं, वो तो टाइम तो पूरा 24 घंटा है हमारे पास। टाइम की कमी नहीं है।
ओके सर अभी
तुम्हारे के लिए मैं बोल रहा हूँ, बस
हाफ एन आवर
रेस्ट लेना है।
हाफ एन आवर में सर हो जाएगा मैक्सिमम।
खाना
जाऊंगा। Okay, so I have shared my code here. Okay, you can click on this chat box and you can get the this code here. So जैसे आप उसको क्लिक करेंगे, whenever you will click on there, the whole code will run, and you could see here, since I have run it for whole here, this last line, I have run it for whole world. So NDVI for whole of the world is being displayed here. Depending upon my net speed, all the imagery will get loaded. Okay. So likewise, we can do NDVI. And suppose we can use this inspector, and if I will click it anywhere, then what we say this time series. The time series of whole NDVI will be displayed for that place of interest. See here that this series is generated. If I will click on this tab, the whole time series with date. See, everything is been displayed here over my over my point of any point. Suppose I want to see the time series of NDVI for any place. Suppose I will go to Lucknow, and there is some vegetation here. I will go to Lucknow. Suppose there is some vegetation here, this part. I will click it here, and using this same code, NDVI collection will be generated, and this whole series, that whole time series of NDVI will be generated. So just by clicking on a simple single place, you get to know the NDVI of whole of this place starting from 2013 to 2022. So suppose you want to work on NDVI time series or some other indecisive time series, you can simply use this code, and this code will give you the time series of any place, any of the place. Okay. Then similar thing we can do with NDWI also. For NDWI, what we have to do? We know that band combination for NDWI is band number 3 and band number 5. So here I have written the function for NDWI. Here band number 3 is there, band number 5 is there. The similar process that what I have followed for NDVI, the same thing I will follow for NDWI. Just the band combination I will change 3 and 5, and rest everything will remain the same. And now when I will click it here, table is nothing but AOI. Now NDVI will also be computed, and I was doing for this place. NDWI will also be computed. See, all the name will come here, and the collection means the whole time series will also be generated. Suppose if I will click on this water body, this Ganga river, just clicking on inspector and clicking on this river, you will see in this collection the whole series of 518 images. All the 518 images has been processed, and the value of NDVI, NDWI time series is also displayed. And this NDVI also is generated. So these few lines of code, only 3-4 lines of code can give you the information of this whole NDVI, NDWI, your Landsat information. All these things could be done just by writing some simple lines of code. So you have got this link, so you can try for your region of interest, and you can tell what is the value of NDVI or NDWI over that place. So up to this part, if anyone has some doubt, please ask. Okay, this is our whole collection. Okay, so if you have any doubt, then please tell me. All these things is actually not required. And if you wish to export this file, you will just write the same line that I have told you for the DEM visualization. That same line could be written export image to drive in the name of, suppose you want to export NDWI, so you will copy this NDWI visualization line. This you can give the name of the folder, then you can give the name of the description. Suppose this is NDWI or MIAOI. Region should be your area of interest, AOI. Scale, as you know, the Landsat has scale of 30, so I am giving it scale 30. Maximum pixel I am providing 111. Then when I will click on run, in my task, this NDWI AOI will come, and after running, NDWI for my place of interest will be exported to my drive. Okay, so the whole process is similar. You just have to learn some few lines of code and you can apply it to any image collection and any kind of image, whether it is single band or multi-band imagery, you can do this. So this, likewise you can do for NDWI, you can do it for NDVI, and even you can do for some other indexes. If you know the correct combination, you can do it for. See here, it gets exported, NDWI AOI gets exported to my drive. From there I can download and visualize it to my in QGIS. Likewise, all these processes are done in Google Earth Engine. So you have to explore this page. This time-lapse page is important in order to mark your area of interest and your area of work. You can use this time-lapse, and this dataset page, you get to know the information of all the imageries that are present in this Earth Engine dataset and how to use that imagery in a form of a code. So if you want to work on Landsat, you just click on Landsat collection, and for any Landsat 8, Landsat 7, Landsat 8 top of atmosphere that we were working today, there is a code here also. You can even copy this code and you can start working upon. Either you can use my code that I have shared, or you can use this code also. You can copy this code and paste it to your panel and start working. So for Earth Engine, this is simple, that you have everything is given in their catalog page. You just have to visit your catalog page. You can search it for your required image of interest, and then you can look up the name of the band that is provided, the code that is given. You can just copy that code and paste it in your panel and clip it to your area of interest depending upon your shapefile, and export it to your drive for further processing. So likewise, you can use this interface also. I hope you must have understood something that you will use in your research work or in your processing work. So using these codes only, we have created some kind of apps also. There is a method to create some apps also using this interface. You will get to know slowly you get to know about this interface. So we have created a lot of apps for our customer who want to work on some various aspects of remote sensing. Likewise, I can show you one example. Like we have developed a portal for Chhattisgarh Forest Department that will be launched soon. So this portal, we have used Earth Engine only. We have used Earth Engine interface, and we have provided them the some
सचिन
app.
सचिन
Yes, sir.
माजिद,
Yes, sir.
ये देखो, ये वाला चीज बहुत बढ़िया है, तुम भी करवाओ अपने यहाँ,
जी जी
बनवाओ।
जी सर, देख रहा हूँ सर।
ठीक है, बताओ सचिन।
Yes, sir. Thank you, sir. Sir, so this panel we have created for Chhattisgarh Forest Department. So what we are providing here, we are giving them some various apps in the form of an app. We are giving them the power of visualization of the forest cover in their place of interest. So there are some apps that we have created, like NDVI time series app, NDVI split panel app, then NDWI split panel app, forest change visualization app, and also forest fire visualization app. Likewise, so what they can do, they can visit using this portal. Suppose they want to get to know the time series of an region, so they will click on this link. One page will open. Okay. In this page, that Earth Engine interface will be loaded here. Okay. So either we can use this interface, or you can, if you want to view on in full page, you will click on full page. So this time series page will open, and it is specially designed for Chhattisgarh. So we have kept it to the shapefile of Chhattisgarh. And then suppose you want to know the time series of this point. So we will just click on that point, and a chart will be displayed. In that chart, we have already filtered all the data set which is having cloud cover more than 10. We have already filtered out, and only those images which are having less cloud cover and were displaying good, that we have kept it here. And this time series of NDVI could be seen, and we can even download this CSV, and we can do it further time series and trend analysis, whether it is increasing, decreasing. That kind of work we can do, and clicking anywhere on the place will give me the chart. So likewise, we have also created one Landsat NDVI split panel. Means we have used Landsat imagery, and there is a split panel in the middle. In that split panel, we can change the date here. Left side, we can click some date. Suppose you want to visualize what are the change that has occurred from October 2001 to, suppose you want to check for October 2020. So the changes could be visualized. Suppose I'm giving it for March. Whatever month that I want to work upon, I can just give the year and the date of that month, and we can simply see just by sliding. Since June has got a lot of so I am taking month of March or Feb. 2007, 2008 I was having with Landsat 7. Suppose this is Landsat 8. From 2013 September to March 2020. So likewise, we can just use this slide panel, and we can detect the change. Similarly, for forest fire also, we can visualize the place where the forest fire has occurred. This could be done for, we have used some certain band combination, and using that band combination, we have tried to identify the burnt area. Means burnt area, we tried to visualize it. So you could see recently in the month of March, the forest fire has occurred in Chhattisgarh, and there you'll see in the month of March you could see some fire spots are there. There are some fire spot that has occurred here also, you could see. And then here, if you zoom out, you will see the whole area, this whole forested area to the border of Odisha and Chhattisgarh, that has got burnt. There is a patch. There is a very dark patch here that could be seen. So using some certain band combination, we are able to identify the fire region, and we can even change the date. This we have developed for future dates also. Whenever that imagery will come, it will automatically take. For the past date also, suppose if you know the date, so this way has been prepared using Sentinel. So every weekly composite has been prepared. Every weekly composite has been prepared, and you can just check the change over certain week, whether last year also the same thing has occurred or not, or at what time range that thing has occurred. So likewise, you can do some kind of analysis. So just for a research purpose, we have developed this portal for them. And then there is one forest change visualization also, in which we have provided them what is the area of loss that the forest has seen over a place of earth, over certain time. Suppose I am selecting it year to be 2018. So these are the red spot where the forest loss has occurred, and gray spots are the water body. And also here in the bottom you could see the chart, how much area this whole Chhattisgarh region has lost over time up to this date in which I have selected. Suppose I selected 2018. So up to 2018, how much area gets lost every year? So you could see in the year 2011, a lot of forest area has been lost. It could be due to forest fire or forest cutting. There could be certain reason, and in other time also there has been certain loss. And also forest percentage tree cover also could be visualized ki how much area is having percentage of tree cover more than 75, more than 50. Likewise this portal could be developed. This whole has a background of Google Earth engine, and this kind of things could be prepared and could be used for various purposes. Similarly, we can do it for water also. We can, since we are doing for also, we can do for snow also. There is a lot of application that could be done. So this is just a gist of that. So this kind of work we are into. We try to provide to all the person out there, those who want to know the status of their forest cover or their natural resources. We try to give them, and we try to use Google Earth Engine as an interface. So I hope you might have you have got some idea about this thing. Similarly, we have done it for forest fire of Australia also. We have developed a portal also, and we have published a paper also in there. So you could see in the month of December, we know in 2019, a lot of forest fire has occurred. So we have used Sentinel. See the patches of forest fire could be seen. So December also, the whole area got burned. Live burning is also could be visualized here. So likewise, certain apps could be built and could be shown. And similar thing we have done for some flood also. This cyclone visualization also we have tried to use the weather data set of all region, like GPM data set, TRMM data set, that we have tried to use, and we try to prepare a precipitation map. And in 17 around 17 to 20 May, I think the Amphan has occurred. So you can easily see the wave that has been generated here. Previously, it was not there on 17, it was there. Likewise, you can just change the date and you can track how this is moving. See, it is moving toward this part. Likewise, it has changed. So certain apps we have developed for our research, and something it looks good also is to in order to work. If you are in this field, so all the natural disaster that is occurring, it is good if you are trying to develop some kind of portal and you are trying to give it to the local person so that they know what is the current status of that hazard, and they get to some safer places quickly. Likewise, it has got a lot of applications. So I hope you might have understood something from the today's session. If you have any doubt, then please ask. Or otherwise, we will just stop it here. And sir, please proceed.
Hello, sir. Hello.
Hello, hello, ma'am.
Can you show the how to download Sentinel to MSI data?
Which data, ma'am?
Sentinel 2.
Okay, Sentinel-2. Okay, since we have learned how to export the Landsat data set, so the similar thing we can do it for Sentinel also. Nothing much. We will just Am I audible? Okay. So So we will search it here, Sentinel-2, okay, and level 1C MSI. We will click on import. We will write this name as S2. We will, as I've told in the case of them, what we were doing, we were just searching for the name, then importing that data, then clicking on that data. We will try to read for what date it is available. Then we will try to check the bands, how many bands are there, what are the band combination that we can apply accordingly. Then we will click on this corner button. It will take me to the dataset page. The dataset page has the information of calling that Sentinel imagery. So either I can copy this whole code, or I will just open in a new code editor. Okay. So, okay. So this whole code has been copied here. I can just run. While running, if you will read this code, it is calling that code, it is filtering to 2018, and then it is filtering for cloud. In the case of Sentinel, we don't use cloud cover less than something, but here we use cloudy pixel percentage, because the Sentinel has got the metadata of cloud in the form of cloudy pixel percentage. So we use this code, cloudy pixel percentage less than 20. Okay, and then we are using one function. I am mapping it over all the functions. Means what this function is doing, this function is removing some extra. This function is trying to mask the extra cloud. So it has some got inbuilt function of cloud masking and Cirrus cloud masking. Using that part, it is trying to mask away the cloud. So I think people have already given that code, so we don't have to change anything. We just have to copy the code from their page, and we just have to paste it here. Okay. And what we can even do, if it is taking more time, then what we can do, we can just clip it to our area of interest. Clip it to our AOI. And since AOI is not there, so I will create one AOI over Jaipur. Okay. I will type it here, AOI. This imagery over Jaipur will come. See here, the imagery is there. Okay, now you have the Sentinel imagery for this Jaipur region. Okay, now that export command, if you want to export, either you can upload your shapefile and give it to the name as AOI, or if I want to export it to my AOI, I will just copy that code where that export line that I have told. The same line will be used everywhere. This same export. Okay, I will copy this code. I will just paste it. Export. Here I will just change the name. Here my name is dataset median.clip AOI. I will just copy this line. Paste it here. My folder will be same. Image is Sentinel-2. Sentinel-2. You have to remember that there should not be any space in the name. Okay. There should not be any space in the folder name or description name. Otherwise, it will give an error. Okay, and it should be in inverted comma. AOI and the scale I know for Sentinel it is 10 meter. So I will give scale to be 10, maximum pixel 111. When I will run, a task will be created by the name Sentinel-2 AOI. I will run again. So what this will do, this will export the Sentinel imagery of my place of interest. I am just sharing this code so that everyone can use it. Okay. In order to share the to code to anyone, we have to click on get link. Some codes will be generated here in the last. We have to copy this whole link, copy, and we can paste it anywhere. So I am pasting it in the chat box. Okay. I'm sending the code for this Sentinel, which is above one. Previous code which I was using for Landsat also, that also I am copying. Okay, that indices generation code. That code also I will copy and I will share it to everyone. Okay. So like this, you can use both Landsat as well as Sentinel, and you can export it to your region of interest. For any imagery, if you want to export, you just have to search that imagery. Suppose you want to work on some pollution data set. It is from Sentinel-5. Just click on this data set, then click on the link, go to the page, copy their code, or open in a new code editor. Just write .clip AOI and paste your exporting command, and that image will be exported. See, here is the code. Remove this center part line. This line you have to remove. You have to just click to your AOI. You have to create one AOI. Create your AOI. Name of the geometry you have to change. AOI, and that export part you have to keep it somewhere. Yes, this thing you can copy and you can paste. Sorry. Okay, I have pasted, and the name I have to change it. Collection dot mean dot clip, and this thing. And whatever this is doing, this is suppose NO2 Sentinel 5. And the ISCA resolution, it is in 1000 meter. That resolution we have to check every time. The code which I am copying, I have to just check the band information as I told. What is the name? What is the resolution? Here it is around 1100. So that thing we have to use it here. 1100. And then if I will click on run, sorry here, 1100. When I click on run, then this NO2 imagery will be exported. So any imagery you can just export just by copying the code from their homepage. You can just change your date. You can change your AOI. You have to click to your AOI and just export it. So you can, all the imagery that are available in their platform, you can use it likewise. You don't have to go to any other portal in order to download. From the Earth Angel portal itself, you can download various images. Okay, anything else?
No, I feel
Yes, yes,
it's okay. And rest, if they'll have any problem, they can contact me.
yes, sir, for sure. You can contact RB services anytime at gmail.com. We will be happy to help you. So I'm stopping screen. Yes.
Uh, again, what was the feedback like? If few of the participants can give their feedback
Yes, please.
right now on verbal. Anyone? The kind of
So it
training.
is very new experience. We are using Google Earth already, but Google Earth engine, it is very new and it is very useful, sir.
Anybody else?
Sir, it was very good, sir. Like it made lot easier to download satellite imagery and analysis.
Yeah.
Thank you so much, sir.
So what I can assure you that the team R-based services are the best in India in terms of Google Earth engine, web programming, web GIS portion. They're very strong team as an individual, and if you will see them, they're young brigades. Hardly they are 25 or 27 years in age. सचिन सही बता रहा हूँ ना, ज्यादा तो नहीं बता दिया.
नहीं सर, ठीक है.
So So they're too young and they're too energetic. And since uh, beginning, I was associated with them. Hari Case, he's a close friend of mine, my student, and now they are what authors of some of the scientific papers that we are doing parallelly as a team. And we are fortunate that our university is having a collaboration with R based services, because R here is here for R based stands for research based. So the biggest advantage that in any private organization, if you are going and they are too good in maybe in script writing or programming or creation of database or web links, but their orientation is for money making. It's generally they're obtaining a lot of money through governments or private projects. But when it comes to R based services, because R stands for resource, that's why we both are together, the R based services as well as Gyan Vihar University. So the common point of interest was research, and we hope that in near future also we will be coming up more good high impact factor publication in high impact factor journals, as we have already done and we are doing it. Within this week, we are going to upload one more paper on air pollution and COVID to some high impact factor journals. And I thank on behalf of Center for Climate Change and Water Research. I thank the entire team from what are based services.
Sir,
Yeah,
sir, I have a question, sir.
who's this?
Sir, can we write a code for a specific building, like India Gate or any place we want to mark on the map?
uh, Writing a code in which regard means you want.
For a specific, like a historical monument or a specific famous building, like India Gate, Rashtrapati Bhavan, etc.
So you
We
want
want to.
actually see what the satellite image does. It works
अपने
over.
आप को म्यूट करेगा वो?
जी सर, सर आप कुछ बोल रहे हैं?
हाँ हाँ, अब तुम बोलो। वो पैरेलली इको हो रहा था, वो म्यूट
अच्छा
नहीं करता था।
अच्छा जैसे कि जैसे एक पर्टिकुलर मॉन्यूमेंट विल बी सी इफ यू विल सी द रिजोल्यूशन ऑफ सैटेलाइट इमेजरी. So mostly the free data that is available from NASA or other space agency that are having a coarser resolution like 30 meter, 60 meter, 100 meter, 1000 meter. So for a particular monument, if you want to work upon, so that should have a very high resolution. Means it should be close to 1 meter, 1 meter, 3 meter, not more than that. So that imagery is not given free, but you can purchase that kind of imagery, and you can work upon certain aspect like uh, uh, like 3D visualization part and some pollution monitoring also. But that thing should be done in very high resolution imagery that is not available with a free domain. So that part becomes a bit tough. So you have to carry out some other survey like lidar survey or some what we say a UAV survey. That thing could be done for the particular monument, and certain studies could be performed by writing code. By writing code also. Code could be written for anything. For all the processing that you are doing, it could be written with the help of a code, or you can use some software. So that is
So
possible.
sir,
Yes.
I just wanted to add one point that as far as marking a point is considered, now that you wanted to mark a monument on the map, now it's just like the Google Earth. If you have this, that we have the geometric tools in the lower left corner. You can simply pick the pointer, can mark it down any place, just like that you are marking in the Google Earth. Here also you can mark any place. You can give the name as well, and depending upon it you can search the data, and then you can sort the data sets on that specific location.
Yes. Yes.
Okay, sir. Okay, sir. Thank you, sir.
So once again, from Center for Climate Change and Water Research, I would like to give a big thank to the entire R-based services that they have given us the entire day. They have trained us on the latest technique of Google Earth Engine, and I'm very thankful to Vishal Sharma, Director R-based services, and also thankful to Mr. Vaibhav Srivastava, Director R-based services for hands-on training on Google Earth Engine. Also, from deep from my heart, I am very thankful to Mr. Sachidanand Pathak from R-Base Services for his the second half in detail programming that he has taught to all the participants, from my students ranging to the DST participants. And finally, all the credit I'll goes to Mr. Harikesh Singh, who is a close friend of mine and the director of our base services. That because of his coordination and cooperation throughout the from his school days till date, we are into a continuous. He's just like a brother to me, and whenever I am in some difficulty in terms of any programming based some what response to reviewer is required, so he will be always helping me out in that regard, and my students and we as an individual are always being benefited for his continuous cooperation. So we are very fortunate that our base services team are continuously helping us out. Last year also we conducted workshop for 3 days, I guess, when there was no corona. Maybe not last year, maybe 2020 or 2019. So for our programming language. So this R-based services are regularly conducting workshops, seminars on advancement of Google Earth Engine, Python. So any of the university institution, if you want to conduct any kind of seminars, conferences, workshop, they can help you out in that regard, and you can train your own students who wants to pursue their future in high-end machine learning languages. So you can have a continuous contact with them, and that will be a great help to the entire student fraternity. And with this, again, a successful day of DST sponsored winter school organized by SGVU is near to completion. Again, tomorrow, with fresh speakers from different central and state remote sensing center, they'll be coming up with uh, their talk on introduction to WebGIS, and in the second half, we'll have practicals. Until then, again, take care. Bye. Enjoy.
Thank you
And
so much.
officially, I'm declaring it closed for today. Okay. Thanks.
Thank you so
Thanks,
much.
Thank you,
RBS
sir.
team. Thanks.